Good morning, good afternoon, and good evening. Welcome to none other than the Crazy Hat Chemist. That's right, folks. Here is the Crazy Hat Chemist with another video. Today's video is on chemical reactions worksheet number 1. Before we actually get started on this video, I highly recommend that you watch a previous video. That video is the Introduction to Types of Chemical Reactions. It's in this same playlist. It's probably at the top. So, without further ado, what we're going to be doing here today is we're going to be identifying each different type of chemical reaction. There are 5 basic types of chemical reactions. So, let's highlight those first of all. The first one is a double displacement or a double replacement reaction. That's one. A second is a single displacement or a single displacement. Then we have a combustion. Then we have a decomposition. And then we also have a combination. So those are our 5 basic types of chemical reactions. So what we need to do is identify from the reactants what type of chemical reaction each one of these is, and they follow specific patterns. So an analogy for you is the following. I'm going to organize, or we are going to organize a little bit in your kitchen. We have spoons, forks, knives, cups, and plates. And each of these has their own unique characteristics that set them apart from the other objects. So every spoon we're going to categorize into one pile. Every fork we're going to categorize those into another pile. Every knife we're going to categorize those into another pile. So just like we have a fork, a spoon, and a knife. So each one of these has their own unique characteristics. So these would be examples of 3 different types of reactions. So I can compile all the forks together. You notice the forks, they have different characteristics than spoons and knives, and spoons have different characteristics than either forks or spoons. So each one of these has their own unique characteristic. So let's get started with looking at these chemical reactions. So problem number one, that is, we have zinc and hydrochloric acid. So zinc is an element. It's an element of which is by itself, it's not combined with another element. And then hydrochloric acid is composed of a cation and an anion. Cations are positively charged, anions are negatively charged. So I call this a cation anion. That's California. So this is a characteristic pattern that's associated with a single displacement type of reaction. Perfect. Okay. The next one, problem number 2. Okay, problem number 2, I have calcium hydroxide with hydrochloric acid. Calcium is a cation, hydroxide is a polyatomic anion. That is a cation-anion combination. And just like on problem number 1, hydrochloric acid is composed of a cation of hydrogen and chloride as an anion. That is a cation-anion. So when I see 2 Californias separated by a plus sign, that means it's a double displacement or a double replacement reaction. Perfect. All right, our next one here, I am going to have carbons and hydrogens plus molecular oxygen. So molecular oxygen, what is that? Molecular oxygen is an element, I do get that, but it is diatomic and it is a gas. And then I have this characteristic pattern of carbons and hydrogens of any number, X and Y. It just so happens that there's 4 of them. This is characteristic of a combustion reaction. All right, our next one here is number 4. Number 4, I have a lithium chloride. By the way, number 3 was methane plus oxygen. That's a combustion reaction. The next one here, number 4, was lithium chloride plus fluorine, and that is a cation anion. That's a California. And then we have this right here, fluorine. That is an element. As you can see, number 4 and number 1 are in the same pattern. That pattern is a single displacement reaction, which is following the pattern of an element plus a California, single displacement or single replacement. Okay. All right, perfect. You guys are doing a fantastic job. Hang on, you're doing great. Okay, this next one, number 5, is hydrogen peroxide. Now, you notice that there is no plus sign separating out the reactants. There is only a single reactant. When there is a single reactant, this is the easiest one to identify, and this is a decomposition. Decomposition, when you have a single reactant. Okay, number 6, we have chlorine plus sodium iodide. Chlorine is an element all by itself. It is diatomic. And then we have sodium cation iodide anion. That is a California. That is going to follow the single displacement type of pattern. Now, I do want you to see that number 4 and number 6 are pretty much the same. Number 1, 4, and 6 are pretty much the same. Okay. All right, perfect. You guys are doing great. What I'm going to have to do is slide this worksheet on up here. And here we go. Sliding on up. We've just done number 6. So let's continue on. All right. So number 7. Number 7 says the following. We have copper plus silver nitrate. Okay, copper is an element. It is monoatomic. That's why it's not 2 coppers. And then silver is a cation. Nitrate is a polyatomic anion. So that is a California. This is also a single displacement type of reaction. By the way, just as we are here taking a look at these problems here, I just want to highlight something here with problem number 6 and problem number 7. There are 2 different types of single displacement reactions. One, the element is a non-metal, as in number 6. One, the element is a metal in number 7. And so those are the 2 characteristic types of single displacement reactions. Okay, perfect. Next one is number 8. Number 8, I have magnesium, which is an element. I have oxygen, which is an element. Neither one of these are compounds, unlike silver nitrate is a compound. It does have molecular oxygen, so I might be thinking it's a combustion reaction. However, it doesn't have carbons, hydrogens, or oxygens. No carbons, hydrogens, or oxygens. It's no California, so then, of course, it cannot be a single or double displacement. So therefore, this is going to be a combination. Combination type of reaction. Okay, perfect. Good, awesome, looking great. All right, our next one here is number 9. We have potassium iodide and plumbous nitrate. That is a cation anion, so that's a California, and that's a cation polyatomic anion, that is also a California. This is characteristic of a double displacement reaction. All right, you guys are doing a fantastic job. We're going to scroll this on up here just a little bit more and move my little paperweights down as well. All right, the next one here. Next one, which is number 10. I have carbons and hydrogens in any number. That's 3 carbons and 8 hydrogens. The numbers 3 and 8 don't really matter. What matters is that I have carbons and hydrogens plus molecular oxygen. This is very similar to problem number 3. Let's just slide that up there so that you can see problem number 3. This is characteristic of a combustion reaction. Okay, perfect. All right, and then let's slide this on up just a little bit more. All right, perfect. Number 11. Number 11, I have only one reactant. So only a single reactant. There is no plus sign in between these. That means that these are actually truly the easiest ones to identify. Like I said, this is very similar to number 5. That's why I have it at the top. This is a decomposition. Perfecto. All right, the next one Now the next one is probably the trickiest, number 12. It's probably the trickiest problem that we have here. Okay. We have a gas bubbled into water. This is actually how we make acids. Um, Most commonly, many of the most important acids are made this way. Okay, this would be nitric acid. And so this is dinitrogen pentoxide is bubbled into water. So when you have a gas bubbled into water, okay, you notice that this is going to be a combination. Boy, it just started raining here, folks, pretty hard on my roof. So this is a combination reaction. Now, this is a binary nonmetal compound. That is two nonmetals. That's binary nonmetal compound. This is not combined in a cation anion orientation. That's why this is not a California. Okay, so that's why this is not a double displacement. All right, fantastic. Now we're going to move on to problem number 13. I'm going to slide this on up here just a little bit. Perfecto. And for problem number 13, I have carbons and hydrogens in any number plus molecular oxygen. That is a combustion. Just like problem number 10 right above it. Okay, fantastic. Number 14. Number 14, I have an element and another element. Notice that I have oxygen just like I had on 13. However, the other reactant is just iron. It is not carbons and hydrogens. Therefore, it cannot be a combustion like number 13. There is no California, so it cannot be a single or double displacement. And there's not just one thing, so that means it cannot be a decomposition. So this must be a combination. All right, fantastic. We're going to slide this on up here just a little bit more. Okay, and now we have number 15. Number 15, we have calcium oxide plus nitric acid. And so calcium is a cation, oxide is an anion. This is common, typical California. Nitric acid, cation, and polyatomic anion, that's also a California. This is characteristic of a double displacement reaction. As you can see, the same pattern is showing with number 9. So double displacement, double replacement reaction. All right, sliding this on up some more here. Did you know that this video is sponsored then the one, the only, the Crazy Hat Chemist? That's right, folks. The one and only, the Crazy Hat Chemist. That's me. It's sponsored by myself. I have no other sponsors. It's just me. Maybe someday someone will sponsor me, but in the meantime, it's just me here. All right, here we go. We got 3 more problems to do. Number 16, we have sodium chlorate. And there is no other reactant. There is a single reactant. That means that this is very similar to number 11 right up there. That is a decomposition. All right, the next one, number 17, I have hydrogen gas and nitrogen gas. These are both elements. Doesn't matter that they're diatomics, but they're both elements. And that means that this is going to be a combination. And you can see the similarity with this one and number 14 right above. All right. And then our final reaction, which will be, again, our easiest types of reactions to identify. When there is only one reactant, that means no plus sign in between them, like here on number 17, only one reactant. That is going to be a decomposition. All right, fantastic. That is the end of this worksheet. I hope you enjoyed this and I hope you learned something as well. I am the Crazy Hat Chemist. Please like and subscribe and give me all that good fun stuff. Love you a lot and I'll talk to you later. Bye for now.